So in this review, we're going to go ahead and go over systems of equations with the main focus on the odd questions. The full answer sheet will be provided as a PDF and posted in our Google Classroom. In the first problem, we're asked to determine if negative 3, 1 is a solution to the system y equals negative 1/3 x and 4y equals 3x minus 12. For it to be a solution, it has to make both equations true. And the way we determine that is by substituting the values in. So this would be my x, the 1 is my y. So I'm going to go ahead and take the first equation. Okay, so here's my first equation, and I'm going to write it as, instead of y, I'm going to take the y value of 1 equals negative 1/3, and I'm going to multiply by the x value of negative 3. And then from here you can type it into the calculator. I have 1 is 1 equal to negative 1/3 times negative 3. A negative times a negative is a positive. And then you have 1 times 3 over 3 times 1, which is indeed 1. So this one is true. Now we got to go and check the second equation. So the second equation is going to be 4 times the y value of 1 equals 3 times the x value of negative 3 minus 12. 4 times 1 is 4. Bring down the equals. 3 times negative 3 is negative 9. Bring down the minus 12. And then we get 4 is equal to negative 13. This is not true, so our answer here is no. No, negative 3, 1 is not a solution to the system. Okay, the next one, question 5, and I know my numbering's off. This just how it was printed on your review, so I left it. So the next one, number 5, I understand that directions tell us to solve by graphing, but as mentioned in class, you do not have to solve by a specific form. If you want to solve by substitution or if you want to solve by elimination, by all means go for it. And if I look at this problem, I'm going to notice that it's in standard form. And because it's in standard form, I'm going to go ahead and solve by elimination. That doesn't mean you have to either. That's just what I'm going to choose to do. So if I'm going to solve by elimination, I'm going to go ahead and come take a look at the variables. I have a 3x and a negative x, 9y and 2y. Based off what's here, I'm going to find it more beneficial to go ahead and eliminate the x, because I already have a positive and a negative. I just need to make this a negative 3x. So I'm going to do that, we need to multiply by a positive 3. Okay. So I'm going to take the second equation, and I'm going to multiply the entire bottom by a 3. Okay. So this comes negative 3x plus 6y equals a negative 24. So this bottom equation, every term was multiplied by this positive 3, giving me negative 3x plus 6y equals negative 24. I'm going to go ahead and write the top equation above. Nothing's changing. It's still 3x plus 9y.
Good morning, Grants. Please stand for the...
Okay, so we have our two equations. They're above each other.
Thank you. You may be seated.
So from here, I'm just going to go ahead and add everything going straight down. Here, my 3x's are going to cancel out. 9y plus 6y gives me 15y, and this is equal to negative 45. Divide both sides by 15, and we get y has a value of negative 3. So for our solution, we have a y value of negative 3. We're going to go back and find the x value. So it doesn't matter which equation you pick. I'm going to go ahead and use this first one. So I'm going to rewrite it. 3, I'm looking for x, plus 9 times my y value, which we solved to be a negative 3, equals negative 21. That leaves us with 3x minus 27 equals negative 21. Add 27 to both sides. So 3x equals a positive 6, which means x has a value of 2. So our answer as an ordered pair is 2, negative 3. On question 7, I'm going to go ahead and solve using elimination because this is a method most of you are choosing to go with. Remember, when you're solving using elimination, the equations need to be set up in standard form. In looking at these two equations, the first one, 3x minus 4y equals 20, that one is already in standard form, so that one's good to go. Unfortunately, the second equation is not. I have 5y plus x plus 5 equals 0. The first thing we need to do is move this 5. We're going to do that using inverse operation. So I'm going to minus 5 from both sides. That leaves me with 5y plus x equals negative 5. The second thing that I want to do is switch the 5y and the x, because standard form states ax plus by equals c. So we need to have the x and then the y, not y and then x. So I'm just going to switch those around. I'm not going to change the value. So it's my x is an x plus my 5y equals negative 5. So I'm looking at this first equation and this equation. Everything else, I'm just going to kind of zone out right now. I don't need them. So I have 3x and negative 4y as the coefficients versus x and 5y. If I want to solve using elimination, I'm going to choose to get a negative 3 here. So my positive 3x, and then I could have a negative 3x. Those would cancel out. In order for us to get a negative 3, we got to multiply the entire equation by negative 3. So this becomes a negative 3x minus 15y equals a positive 15. Because negative 3 times negative 5 is a positive 15. Then I'm going to bring this equation and I'm going to write it above. So that way they're stacked nice and neat. Is 20. So now we're going to go ahead and add everything going straight down. The 3x's cancel out. Negative 4y minus 15y is negative 19y. And then 20 plus 15 comes out to 35. From here, we have to divide both sides by negative 19. So this is going to leave us with y equals 35 over negative 19. Now I'm going to go ahead and leave that as a fraction. Okay, from here I'm going to need to find the x value. So our ordered pair, we know the y value is 35 over negative 19. By the way, you will see some decimals or fractions on your test tomorrow. They're okay. the process is still the same. So from here, I'm going to choose to go ahead and use the first equation. Oops. I'm going to use this first equation. So I'm going to rewrite it down here. And instead of y, I'm going to use what we got here in place of y. Okay? So this is going to be 3 times x minus 4 times the y value of 35 over negative 19 equals 20. This is where a calculator would be very helpful, very nice. So 3x, negative 4 times negative 35 over 19 is become a positive. Okay, we type it in and we get positive 140 over 19. If you wanted to change this into a decimal, by all means go for it. Still equals 20. Our next step is going to be to subtract that 140 over 19 from both sides. So the 3x is going to stay. Once again, using the calculator, it's going to be 20 minus, I'm going to make sure you have a fraction of 140 over 19, or if you put it in form of a decimal, that works. This gives me 240 over 19, or you could say 12.63, and then divide both sides by 3, and we get a final x value of 80 over 19, or if you have a decimal, you could say 4.21. And just because I have my y value in the form of a fraction, I'm going to go ahead and leave this one as well. But you could convert either one here. Or if you have decimals, it would be 4.21 and negative. Give me a moment. You could say, or negative 1.84. Either one work. So in this question, I'm going to go ahead and solve by graphing. And I'm going to do this. I'm going to go ahead and label. This is y1. And this equation has a slope of -3 and a y-intercept of 9. So the first thing I'm going to do is go ahead and plot a point at the y-intercept of 3, and then I'm going to go down 3 units over 1. It's a negative slope, so I want to make sure my line's going down from left to right. Okay, the next equation I have is not in standard form, or slope-intercept form. So before I do anything else, I need to go ahead and get this in slope-intercept form. And I'm going to do that by adding x to both sides. And that comes out to y equals x minus 3, which gives me a slope of 1 and a y-intercept of -3. So I'm going to go ahead and graph this starting at -3 on the y-axis, and it's going up 1 over 1, up 1 over 1. And then I can see where the two lines cross. And by the way, you will have access to your calculator, so you could also type this into your calculator and look at the graphs on your calculator screen. Either way, you're going to see it has a solution of 3, 0. on this slide, I want you to understand the difference of what a solution looks like when you have a system with one solution, no solution, and infinitely many. And then notice at the bottom, I have to add another row for each table, because we're doing two equations. And you're going to see examples of these tables on your test. Okay, so focusing on a graph with one solution, I'm going to go ahead and start off my first equation. I'm going to graph it in green. And your graphs can look however you want. So let's say I have my y-intercept at 5, and I'm going down to over 3. Down to over 3, and like I said, this could be whatever you want.
Yeah, that's the answer, but I forgot how I did that.
And then getting points on the other side, up to back 3, up to back 3. And then I'm just gonna, I only have 3 spots to put in this table. So I obviously have more than 3 here. I just need to pick any 3 that I want. So I'm gonna go ahead and use this one of -3 and 7. I'll do the y-intercept of 0, 5. And then I'm going to go ahead and go with this 6 value of 6, 1. Now, because I'm picking these points, 3, 0, 0, 5, and 6, 1. When I graph my second equation, I want to make sure that one of these crosses. So I'm going to go ahead and go with this one here.
That's cute.
This I'm going to choose to be my solution. So I'm kind of working backwards here. And then I can pick a slope of, let's do down 3 and over 3. Down 3 over 3, down 3 over 3. Okay, so here's my second line. And then once again, I want to focus on those same y points for the same x coordinate. So here, when x is -3, we have a y value of -8.
Enrique, be quiet.
Here, write your name.
When x is 0, we have a y value of -5.
We're gonna be famous,
No, she's just gonna skip it all and then we're not gonna have to.
And then when x is 6, we have a y value of 1. And then we can see the solution of these lines. The point where they cross is this 6, 1, which we see here. Okay, when we're talking about no solution, that means we're looking at parallel lines. So it doesn't matter. I'm going to go ahead and pick any value, any equation. So let's go with a y-intercept of 3. And I'm going to go up 3 over 1, up 3 over 1. And I'm going to get the points on the other side. Then your lines can be anything that you want. It's just what I'm picking, so I'm going to sketch. Okay, and I'm going to use my points. I'm going to use this one, my y-intercept, and this one. So I'm going to go ahead and write those down in my table. So the first one is -3 with a y value of -6. Then I have my second point is 0, 3, and then the last one I have is 1, 6. Now for my second equation, it needs to have the same slope for it to be no solution. So I can pick my y-intercept of 5, -5, and I'm going to go down 3 over 1, so that way I get parallel lines. Get the points on the other side, up 3 over 1. Okay, so you can see here, my lines aren't the prettiest, but that's okay. And I'm going to use those same values. So this one kind of fell off the graph, which is okay. Okay, so I'm gonna go ahead and write in those y values now. Okay, I'll start with this one. When x is 1, my y value is -2. When x is 0, my y value is -5. And then when x is -5, my y value is, and that comes out to, it would be -14. So I said that one fell off the graph, it's okay. For the last one, we're talking about infinitely many solutions. This is where we have the same line. And you will see questions similar to this here on your test. So it doesn't matter what line you pick. So here I'm just going to do y-intercept of 3 up 2/2. Getting my points on the other side. And yes, up 2/2 would be a slope of 1. So here's my line. And I'm going to go ahead and pick my x points to be this one, and this one. So I'm going to write the